Okay, the very first thing we're going to do is we got to break this velocity. This is an angle magnitude vector, right? Okay, so we got to break that into components. So 57 degrees is like that. It's actually a little steeper than that, right? And that has a horizontal component and a vertical component. And the vertical component is always opposite. I'm always going to give you that angle, right? And this is 25 meters per second, right? And so the vertical component here will always be using the sine, right? So this will be 25 sine 57, just because it's the opposite side, right? And then the horizontal velocity will always be cos. So this will be 25 cos 57. Now just do a quick check. Make sure you are in degrees. In fact, I am. All right, this is good. Okay. So I'm going to go 25 cos 57, enter. 25 sine 57, enter. All right, so I get 13.616 is this component. And that's my horizontal component. And then I get 20.967 for this component. Right? So that's going to go in here. This 13.616, this horizontal component is this guy. It's also this guy, right? And then the initial velocity is 20.967, right? Okay. And then if it hits the ground, and let's figure out the for this thing hitting the ground, right? Okay, so let's have this guy go right, and then hit the ground, right? This is actually 0. There's no net change in vertical displacement, right? I'm not going to use that, but I'm going to use this, right? That the final vertical velocity is just negative 20.967, right? And that comes from our free fall problems, right? Whatever the initial velocity is, the final is negative that if they start and stop at the same elevation, okay? This is, of course, negative 9.8, right? This guy is 0, and those are always true for these, right? The only difference here is that we start off, our initial velocity is these components, right? Okay. So let's figure out what time it's in the air. So let's answer. We've answered B, right? There's B, right? Let's answer C. What time is it in the air? I'm going to use in the vertical side here. I'm going to use. This is the answer to C. VF is VI plus AT, and these are all the same. Every single one is the same. So in a way, these are easier than cliff problems, right? So the final velocity is negative 20.967. And the initial velocity is positive 20.967, right? It goes up, it goes down in the vertical direction, right? Okay, and then that's plus negative 9.8 times t. So that is, let's do this. That is 4.2789 seconds. Right, so 4.2789. And then remember, time can kind of castle across. Is that right? 2789. Yeah. It's actually would be 4.28 seconds. I'm looking on the sheet, it says 4.27, but it really would be 4.28. Okay. And then D says, how far does it go before hitting the ground? Right? Okay, and then that's going to be on this side, right? And that's just x is vt. Right? And I'm using the triangle, right? Just the speed triangle. So velocity times time is displacement. Remember, there's no acceleration, so we can do that on this side. So that guy times the 13.616, and I get 58.26 meters, right? And then what I do is I just multiplied the 13.616 by the 4.2789. Right, so this guy times this guy, right? Or this guy times this guy, they're the same, right? Okay, just x times time. So that's our answer to D. E says, what's the greatest height the rocket reaches? Okay, that's going to be an entirely different setup for this, right? So to get to the top, we're going to go x, vi, vf, a, and t, and this is the ground. This is ground to ground, right? It leaves the ground at this velocity, hits the ground going down. But if we go ground to top, Our initial velocity is 20.967. And at the top, our final vertical velocity is 0 right here, right? We're not moving up or down, right? And then this is negative 9.8, okay? And it says, what is the greatest height? And I'm going to choose to use the formula that doesn't have t in it, right? So I'm going to say VF squared is VI squared. You could do it a lot of ways too, right? You can also take that time and divide it in half and use any formula you want, right? Because it's going to reach the top at half the time. I'm going to use this one though. I feel confident about this one. 0 squared is 20.967 squared plus 2 times negative 9.8 times x. Okay, so that guy basically squared divided by 2 divided by 9.8. I'm getting 22.4 meters. And then the final trick question is, what is the speed of the rocket at the highest point? Well, at the highest point, it only has a horizontal velocity because the vertical velocity is 0. So the question is, what is that horizontal velocity, right? And this was, I just answered E was this one, right? So now we're answering F, right? What is that horizontal velocity when it's at the top? Well, the answer is it's the horizontal velocity it's got the whole time. It's the horizontal velocity it started with. It's the horizontal velocity it ends with. It's 13.616. Whatever that horizontal velocity is, it's got it at the top, it's got it halfway up, it's got it the whole time. The horizontal velocity doesn't change, okay? I hope that helps.